Polyether is a colourless organic thermoplastic polymer in the polyaryletherketone family, used in engineering applications. Synthesis: PAEK polymers are obtained by step-growth polymerization by the dealkylation of bisphenol 8 salts. Typical is the reaction of 4,4-difluorobenzophonone with the disodium salt of hydroquinone, which is generated in situ by deprotonation with sodium carbonate. The reaction is conducted around 300 degrees Celsius in polar aprotic solvents, such as diphenyl sulfone. Properties: PAEK is a semi-crystalline thermoplastic with excellent mechanical and chemical resistance properties that are retained to high temperatures. The processing conditions used to mold PAEK can influence the crystallinity, and hence the mechanical properties. The Young's modulus is 3.6 GPa and its tensile strength 90 to 100 MPa. PAEK has a glass transition temperature of around 143 degrees Celsius and melts around 343 degrees Celsius. Some grades have a useful operating temperature of up to 250 degrees Celsius. The thermal conductivity increases nearly linearly versus temperature between room temperature and solidus temperature. It is highly resistant to thermal degradation as well as attack by both organic and aqueous environments. It is attacked by halogens and strong Brunstad and Lewis acids as well as some halogenated compounds and aliphatic hydrocarbons at high temperatures. It dissolves completely in concentrated sulfuric acid at room temperature. Applications: because of its robustness, PAEK is used to fabricate items used in demanding applications, including bearings, piston parts, pumps, HPLC columns, compressor plate valves, and cable insulation. It is one of the few plastics compatible with ultra-high vacuum applications. PAEK is considered an advanced biomaterial used in medical implants. It is finding increased use in spinal fusion devices and reinforcing rods. It is extensively used in the aerospace, automotive, and chemical process industries. PAEK's mechanical properties at elevated temperatures have led to it being used in at least 2 varieties of reprap extruder as thermal insulation. This means the main mechanical structure of the extruder can be made of the same material that is being extruded, provided that the PAEK insulator prevents heat from traveling beyond the intended melt zone. Shape memory PAEK in biomechanical applications: PAEK is not traditionally a shape memory polymer. However, recent advances in processing have allowed shape memory behavior in PAEK with mechanical activation. This technology has expanded to applications in orthopedic surgery. References: A.K. van der Vegte and L.E. Govert, Polymeren, van Ketone.kunststof, ISBN 90-407-2388-5, David Parker, Jan Besink, Hendrik T. van der Gramp, Gary W. Wheatley, Ernst Ulrich Dorf, Edgar Oslinning, Klaus Reinking. Polymers, High Temperature. Ullmann's Encyclopedia of Industrial Chemistry. Wiley VCH, Weinheim, doi, 10.1000/14356721 449 Pub 3. David Chemish Update on the Technology and Applications of Polyaryletherketones 2010. ISBN 978-1-84735-408-2. Material Properties Data, Polyetherketone, www.makeitfrom.com, J. Blum, A. Lindemann, A. Schopper, Influence of the CNT Contents on the Thermophysical Properties of PAEK CNT Composites, Proceedings of the 29th Japan Symposium on Thermophysical Properties, October 8 Euro 2008, Tokyo, Lawson, Michael. Diversified Plastics Incorporated, PAEK Playing Role in Space Probe. PlasticsNews.com. Crane Communications Incorporated. Retrieved May 6, 2012. Anonymous. Surgical Technologies. MED Shape Solutions, Incorporated. Announces first FDA-cleared shape memory PAEK device. Closing of $10 million equity offering. Medical letter on the CDC and FDA. External references, application note on methods of characterizing the crystallinity of PAEK.